Now in this tutorial I'm going to teach the converse of rhombus theorem. Just before I proved rhombus theorem, and in rhombus theorem we proved the diagonals of rhombus are bisected with each other at 90 degree. Now in this tutorial I'll prove it the converse. Converse means this opposite. Opposite means what? Here in theorem we are given is the diagonals are bisected with each other at 90 degree, but here the diagonals are bisected with each other at 90 degree is given, and we have to prove is the rhombus. So let's see the statement. Prove vectorically that if the diagonals of parallelogram are bisected with each other at 90 degree, then it is a rhombus. Okay, now here figure is what? ABCD is a parallelogram. Here is given parallelogram, and their diagonals AC and BD are bisected with each other at 90 degree. This is perpendicular is given, and here we need to prove this ABCD is a rhombus. We have to prove it is a rhombus. So how to show it is a rhombus? Showing rhombus means it is already given parallelogram, so opposite sides are equal, and we need to prove rhombus means is all sides need to be equal. If all sides are equal, then this parallelogram is called rhombus. Okay, now what is given here? Now given is in parallelogram, this is now first given is parallelogram. In parallelogram ABCD, diagonals AC and BD are bisected with each other at 90 degree. They are perpendicular with each other is given. So when the lines are perpendicular, their dot product of vector is 0. So this AC and BD, their dot product AC vector dot BD vector, it is 0. It is given to us, and we need to prove this ABCD is a rhombus. So to prove is ABCD is a rhombus, and proving rhombus means what? We have to show all sides are equal here. Okay, now see here it is a parallelogram, so AB and DC, AD and BC, their opposite sides are equal here. Opposite sides are equal, and if you are able to show either AB equals to AD or AD equals to CD or DC, if you show them, then you can easily say all sides are equal. Here now see, you are already given is AB equals to DC, this equals to this already, and AD equals to BC, AD equals to BC, it is also already given because it is a parallelogram. Now if you are able to show these two are equal, let's say this is AD equals to, let's say, DC, okay, whatever, these two are equal, AD equals to DC. If you show AD equals to DC, then what can you say? This equals to this means what? These all are equal. Let us suppose this equal to this equal to this. If these two are equal, it means these all sides are equal. These all sides are equal. So we can only prove AD equals to DC. AD equals to DC. It means all sides are equal. So let's prove this AD equals to DC. How it can be proved? Now here we are given is AC dot BD equals to 0. So very easy. From here, first let's find AC vector. Then in second number let's find BD vector. After finding these two vectors, let's put them here, and finally let's see the result what happens. Okay, now one number. First let's find AC. Now see in one number how to find AC. Now see for AC there are two triangles, ABC or ACD. Any one of the triangle you can take, no problem. But I'm taking here ACD. Okay, ACD. In triangle ACD, using triangular law of vector addition. So if you take triangular law of vector addition, what can you write here? AC vector equals to AD vector plus DC vector. Okay, so in one number using, okay, you can write in triangle ACD using triangular law of vector addition. Okay, now what can you write is, this is AC vector equals to AD vector plus DC vector. Okay, AC vector plus DC vector. Now in 2 number, similarly in 2 number, you need to find BD vector. BD. Now how to find BD vector? In BD vector now there are 2 triangles again, ABD and BDC. Any one of the triangle you can take and use triangular law of vector addition, but I am taking ABD. ABD. So from here BD vector we have to find. So what is BD vector? BD vector equals to BA vector plus AD vector. Okay, BD vector equals to BA vector plus AD vector. So in triangle ABD, using triangular law of vector addition, you can write BD vector equals to BA vector plus AD vector. Okay, this is. Now first you see here, you need to prove AD and CD, DC, AD and DC. So here let's replace every by AD and DC. Let's write all these vectors in terms of AD and DC. Here is already AD and DC, so fine. So here is now see AD is here, but here let's change first. This is what? Minus AB. BA can be replaced by minus AB. You know the reason is what? Negative vector. This is BA vector equals to minus AB vector. Okay, equals to. Okay, now see here, let's change it, like arrange it AD minus AB. AD minus AB. Now let's take here. There is AD vector, there is also AD vector, but we need DC, we don't need AB vector. So let's replace AB. So AB vector can be replaced by what? DC vector. Okay, so let me replace it. This is AD minus AB vector is what? This is DC vector. So here you can write AB vector equals to DC vector. Yeah, this is the parallelogram. Opposite sides are equal and parallel, so we can replace. Okay, now 3 number. Let's substitute the value of AC and BD in given. So we are given from given. What we are given there? AC vector dot BD vector equals to 0. Or see AC vector. What is AC vector here? This is AD vector plus DC vector dot. What is BD vector here? BD vector is what? AD vector minus DC vector. This equals to 0. Or now it is like A plus B and A minus B. We can easily write AD square minus DC square equals to 0. This is using A plus B, A minus B equals to A square minus B square. So from here see what can we obtain? This is AD square equals to DC square. So therefore AD equals to DC. See, AD equals to DC. AD equals to DC. Now what can you say here is, now 4 number, as it is already AB equals to DC, AB equals to DC and AD equals to BC, AD equals to BC. What is the reason here? Being opposite sides of parallelogram, because opposite sides of parallelogram are equal. So from 3 and 4, see 3 AD, this equal to this. These two are equal. These two are equal means these all are equal. Now 5 number, you can write from 3 and 4, you can write AB equals to BC equals to DC equals to AD. All are equal. As all sides are equal, we can say it is a rhombus. Hence ABCD is a rhombus. Hence proved.